Chapter 6 test is going to have 4 quadratic equations, and you're going to have to use one of each of the 4 methods to solve them. So the first method is by factoring. Factoring is the easiest. That's always our first one we try. And this is a good example of factoring, number 6, on your review. So number 6, if you get all your terms on the same side, so if you move that to the left side for your move number 1, so you have p squared minus 13p plus 42 equals 0. So if you're staring at that, hopefully this can be factored without too much effort on your part. You've done hundreds of these. So factor it, change it, rewrite it as a multiplication problem. What times what's going to give you p squared? So it's going to be p and p. What times what's going to give you 42? But it's going to turn around and add and give you negative 13. So it's going to be a 7 and a 6, and they both must be negative. Okay, now if you're multiplying these two quantities and your answer is 0, you must have multiplied by 0. So one of these two quantities, or maybe both of them, is a 0. So what are you going to plug in here for p when you subtract 7 is 0? So p equals 7. Or what number minus 6 is 0? And p equals 6. There's your two roots. So factoring, that's the first one. That's the easiest. Why do you use it? When do you use it? You got to answer that on the test. You use it when this coefficient of your x squared is a 1. And then right here, when you just recognize that you can find the factors of 42 that add to 13 or add to negative 13. Okay, when you factor them, your answers are always going to be easy numbers. They're going to be in the set of integers. So that's another nice feature of factoring. So you use it. It's the first one on your checklist. You always want to see if you can factor it. And if you can, a big hint is going to be that's going to be 1 in front of the x squared. And it just can easily be factored. So method number 2 is by taking the square roots. And this one is used when the left expression is a perfect square. So if you factor this one, you can factor this one pretty easy. It's going to be x plus 4 times x plus 4 equals 7. But you can rewrite this just as a perfect square. X plus 4 squared equals 7. Okay, now just undo it. Solve for x. Get x all by itself. You got to undo the square. So you got square root the left, square root the right. You got x plus 4 equals plus or minus square root of 7. Minus 4 from both sides. Your answer is x equals a minus 4 plus or minus square root of 7. Okay, when and why? You use it when the left side is a perfect square. Okay, why do you use it? Because factoring is not going to be too slick right here, because if I minus 7 on both sides, I'm going to have x squared plus 8x plus 9 equals 0. Okay, now what two numbers multiply and give you 9 but add and give you 8? And there's no way to do that. You cannot factor this. This is impossible to factor. And if it's impossible to factor, that tells you your answers are not going to be nice and easy and clean. They are going to be a little hairy. So this answer right here, this is in the set of irrational numbers. So square root property, you're going to use it when your answers are going to start to dip into the irrationals and even into the imaginaries. Okay, the third method, completing the square. Okay, look at the left hand side, and it is not a perfect square. So you're going to get rid of this. You're going to minus 3 minus 3. This is problem 17. So you got m squared plus 10m equals a negative 13. Okay, now I want to make it be a perfect square on the left hand side. So you got to ask yourself, I need to add something here And if I do it to the left, you have to do it to the right. What can I add to both sides that's going to make this a perfect square? So you take b, divide it by 2. So b is 10, so I'm going to do 10 divided by 2, that's 5. And then you square it. 5 squared equals 25. So that's my number. I'm going to add 25 here, and I'm going to add 25 here. Alright, now, when you add 25 on the left, you have created a perfect square. So you can rewrite that as m plus 5, that whole quantity squared. On the left, you're going to have a negative 13 plus 25 is just 12. Okay, now you do it just like we did before. Just undo the square. Let's just solve for m. Let's get m all by itself. Square root the left, square root the right. So you're going to have m plus 5 equals plus or minus square root of 12. Hopefully you can see that you can simplify square root of 12. Rewrite it as square root of 4 times square root of 3. Because square root of 4 is a perfect number, so you're going to have plus or minus 2 times the square root of 3 equals m plus 5. Now just minus 5 from both sides, so your final answer is going to be m equals a minus 5 plus or minus 2 times the square root of 3. Okay, again, your answer is not going to be too friendly. It's going to be in the set of irrationals, set of imaginaries. So when do you use completing the square? That's kind of a good question. You're going to use it when you have tried factoring. Factoring doesn't work. When you've tried perfect square, it's not a perfect square. So if it's not a perfect square, and this guy, this b is even, when your b is even, you can totally get rid of the c. You can get it to the other side, and you can make your own square. You can complete the square. So when do you use it? You use it when your left expression is not a perfect square, but b is even. Because 10 divided by 2, if it was 11 divided by 2, that would be 5.5. You're getting into decimals, and then that's kind of funky. So the fourth and final is when it's funky. The fourth and final is your quadratic formula. Okay, the quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So this you use when you've gone through everything else and nothing's going to work. Now what's sweet about this is this will work for any problem, so you can even use this for the easiest type. It's just going to take a little time to plug them all in. So move number 1, get everything on the same side. Keep your x squared positive, so you should rewrite this as 2x squared minus 9x plus 11 equals 0. Identify your a, b, and c. A is going to be 2, b is a negative 9, c is 11, and then just plug them into the formula. So it's going to be x equals negative b, negative 9, plus or minus the square root of b squared, that's 81, minus 4 times 2, that's 8, times c, 8 times 11, that's 88, all divided by 2 times a. 2 times 2, that's 4. Okay. So this one looks like it might not be too bad. Maybe it will be. So I'm going to simplify. Negative 9, that's a positive 9. Plus or minus the square root. Okay, 88 minus 81. I think that's just 7. All divided by 4. Alright, this might be a little ugly. Okay, can we go any further? Square root of 7. Can you simplify square root of 7? Can you divide 7 by 4? No. Can you divide 9 by 4? Simplify that fraction. You're done, I think. That is your answer. 9 plus or minus square root of 7 divided by 4. Okay, these ones, can you go totally backwards? Can you write a quadratic equation if we give you the roots? And this is using the zero product property. you have x plus some number times x plus some number, and your answer is 0. So they're giving you the answers. That's an answer. If you plug in 4 plus what number is a 0? The answer is -4. And if you plug in 5 for x, 5 plus what number is 0? It's got to be -5. Now you just do distributive property. X times x, that's x squared. X times -5, that's -5x. -4 times x, that's -4x. -4 times -5, that's +20. So your final answer, x squared minus 9x plus 20 equals 0. Let's work out one of these. Sketch the graph of each function. Now it's an inequality, and this is a greater than, so that's got to be a dotted line, and then you're going to do some shading. So my eyeballs go right here, and notice that it's a quadratic, so it's going to be some kind of a parabola. It's going to look like one of those two. And I need to find your axis of symmetry. Your axis of symmetry is -b divided by 2a. So let's identify our a, b, and c. A is 1, b is a -4, c is 8. So my axis of symmetry is going to be a -b divided by 2 times a. So I think it is 4 divided by 2. So your axis of symmetry is 2. X equals 2. So come on the x-axis at 2, and let's draw our line of symmetry. Okay, the rest is pretty slick. Start with the vertex. Let's just make a table, x, y, and let's plug in some values. Let's definitely plug in 2, because my vertex is going to be on that line of symmetry. So when I plug in 2, just take it back to your function and drop it in place of x. So x squared, 2 times 2, that's 4. 4 times 2, that's 8. 4 minus 8 is a -4. Plus 8 is 4. So if I go over 2, up 4, right there's my vertex. Now I'm going to stay close to this line of symmetry. I'm going to plug in 1 or 3. I'm going to choose 1. Okay, drop 1 in. 1 squared is 1 minus 4 times 1. It's a -3 plus 8 is 5. So I'm going to go over 1, up 5. And then I get a dot for free because it's symmetric. It reflects across that line. And then this dot is a slick dot right here. 8. It's going to happen if I plug in 0. 0, 8. That's your y-intercept. So on the 0, on the y-axis at 8, I'm going to have a dot there and a dot there. Okay, now connect them, but I got to connect them with the dotted line. And then test a point. Let's test a point. Let's test the origin. Let's test 0, 0. So let's plug x and y. Let's put them both in as zeros. So let's put a 0 right here for the, let me erase this stuff. Let's put 0 for the y. Put 0 for the x. That's going to be 0, that's going to be 0, that's going to be 0. And I'm left with a statement that looks like this. 0 is greater than 8. Is that true or false? 0 is bigger than 8. It's false. So what side am I going to shade? I tested this point and it gave me a false solution, so that must mean my answers are not on the same side as my point, so they must be inside the parabola. Alright, 35 and 36, you're going to have two problems, and they are going to be pretty similar to this. You're going to have to look at a parabola and find the solutions. Okay, let's start with 36. The solutions are right here. So the solutions to this quadratic equation are 1 and 5. X equals 1 and 5. It's wherever your parabola crosses the x-axis. It's the x-intercepts of the parabola. Now number 35 is tricky because it never touches the x-axis. So if it never touches the x-axis, I know my answers are complex. And let's call that good. That's all we're going to do. Complex means they are imaginary numbers. So the answers to this quadratic equation on 35 are two imaginary numbers.